We are all categorizing things every day. It helps us to make better decisions, to act faster. Sometimes we know ahead of time what the categories are that we have to sort certain items into. But more often than not, those categories aren't really established until the process is already going on. The most popular machine learning algorithm that leverages that same concept to make sense of huge amounts of data is k-means clustering. And in today's video, we're going to talk about how it works. Imagine you have a set of n data points that you want to categorize. This data can be represented as a vector, a two-dimensional one in this case. To initiate the process of sorting the given information into appropriate subsets, we have to pick our variable k, the amount of clusters we want to end up with. Let's use the number 3 for this example. If we don't know much about our dataset, we can just choose those points randomly. They will define our new means for each cluster of points around them, which explains why this method is called k-means clustering. Each data point has a defined distance from each mean, and the goal to reach for achieving the best categorization possible is to assign each data point to the mean that is closest to it. Usually we minimize the squared error over all sets here, to penalize outliers strongly and prevent an inappropriate assignment. This procedure results in k different sets, in which each member of the set is closer to its assigned mean than to any other mean. And now, having a first iteration of categories in the first place, we can update the mean of each set by identifying the mean location among the newly assigned members, defining an even better fitting set structure. This process of assigning the data to a set and then updating the mean is repeated as often as necessary until we reach a desired quality of categorization. But how is this quality even measured? In general, k can reach anywhere from 1 to n. 1 being one extreme case in which all data points belong to one cluster, and n the opposite extreme in which every data point has its own cluster. Neither of them is very helpful, so the optimal answer is likely to be found somewhere in between the two. One of the most popular methods to compare different k values after the clusters have been computed is the elbow method, in which we're looking for the point of diminishing returns by plotting explained variation of our model against the amount of clusters used. But this method comes with a lot of problems. So to make a more logic choice, we will continue from here using the silhouette method, to find a k that balances compression and accuracy. The idea of measuring the silhouette is to compute how well a data point fits the currently assigned cluster in comparison to any other cluster that is out there. That is done by calculating the mean distance to any other data point in the same set, identifying the mean distance to the data points of the next closest set, and creating a ratio between the two that gives us back a value between -1 and +1. Where a high value indicates that the object is well matched to its own cluster and poorly matched to neighboring clusters. The mean of S of I over all points of a cluster is a measure of how tightly grouped all the points in the cluster are. Thus, the mean over all data of the entire dataset is a measure of how appropriately the data have been clustered. And that is defined as an adequate way to figure out how good a certain choice for k is, and to see if there's potentially a better one. The explained concepts are something that we're interacting with every day, most of the time without even noticing it. Usually, we are the ones being categorized. It might be our shopping behavior or content history for new recommendations, but also our past credit card usage to detect outliers that might be a potential fraud threat. Through the integration of AI systems in our everyday life, it became something we rely on. It usually doesn't know what's right or wrong, but at least what seems normal and abnormal based on the input it gets. I hope this video helped you to understand the behind the scenes of this machine learning algorithm a bit better. Thank you for watching.